Hello for a quick tutorial / demo for the pen software. We're going to do the basics, nothing else. Day-to-day use, let's just say. Main screen is this one. Shows you licenses and whatever. And recent files. Options. You can select the default settings, where do you save, and so on. Tools, import new tool libraries from different manufacturers. Metallics has pretty much everything from large manufacturers, but you can also import your own DXF or create your own. Don't suggest creating your own. If you want to make something yourself, use a DXF file. Much easier. Materials, well, you can create materials, modify material values. Let's say you have titanium or Stronix or something, you can make them there. Machines, you can change the machine settings, different upper tool holders, lower tool holders, what materials do they have, what are the material names in the machine side, what default tools do you use, so on. Open a file, DXF, Ben's own, or step. I suggest using step files, 3D files always work the best. And a new part, which one we're going to do. 2D parts only, which means profiles. You can create a perfectly new profile if you want. Use a template. Templates also at the same time work as a tutorial / practice, so we'll go through them soon. Base flange. This is a base flange. What's the die selection mode? Is it by default tooling or design radius? Design radius, usually it's the better option. It's basically when you want to make the auto processing / auto tooling. Which one does it use? Bend compensation, is it ISO standard, constant, which is shown here. You can modify it here. Roller is own, because they decided their own, don't ask me why. Or bend compensation table, which is default. When you install the software, it's with Ben's own values. They are pretty close to ISO standard, but not quite. But you can also modify your own if you want to correct it, let's just say. Hard white. What's the length of the flange? Let's say 500 millimeters, 5,500. Material, steel. There's all the materials that the machine our software currently has. Thickness. What's the bend radius? Obviously, when you go default tooling, the bend radius disappears. Design, this one. And selecting templates, Omega 1, it's a pretty simple one, the most basic. And the further you go, the difficulty it gets. So basically, when you go through all these, you can basically have the basic idea on how to do anything. Only the basic idea, obviously, but it's pretty helpful when you first start learning how to use the software. And then we go next. This is designing. You can input flange wherever you want, end or the beginning. Only the beginning, only the end. Edit, which you can also do by selecting from here. It highlights the flange or flange bend step you have selected. Shows height, shows angle, delete step or delete everything. What's the thickness? What's the radius? What are the dimensions? Is it external or internal? By default external usually, but it depends. And here you can see also, is it the selected bend length, height here, internal or external? And here you can basically see the 2D file again. Sorry. So you can see the 2D file here again. Base flange length, you can edit here again if you want. Template name, if you want to save the template by another name. What's the project description, anything. Next step, go to design, which is where we just were, or simulation, where we'll go. Machine name, you can select the machines by default, or when you get the software, it only has the demo machines and the one machine, in this case G40. Tool stations, if you have saved tool stations, which are basically if you want to always keep the tools in the same location, you can save it here. and try to work with them as long as possible. And auto processing will try to do the bends on default tools or tool station setups that you have saved. This machine doesn't have default tools nor station setups, so the auto process doesn't do anything. But when you go to simulation, it opens the part, loads it. Depending on the part and the computer, the speed varies quite a lot. And now the auto processing doesn't do anything. And here's the part, really simple one. In here, you can also reset the tooling workflow or reset. Decide is the design. And here's the order of where we go. First tooling, then sequencing, then simulation, then output. If you do the auto processing properly, it goes straight to simulation. Auto tooling, depending on how many tools you have and how complex the part is, it takes a long time. Or not that long. And here you can see the bends, different parameters, what's the angle, what's the length, and so on. Different colors or different directions. But I always suggest in the beginning, always select the tools so you know what you're doing. You know what tools work with in what situation, so you have the faint idea on how actually bending works before you just trust the computer blindly. Blindly trusting a computer is always a bad idea. But let's just go select the basic punch tool 1193. Pretty basic. Shows you the punch name, manufacturer, this is the ID in the machine itself or software. Punch name, what's the joint, what's the height, working height, radius, angle, max tonnage, is it a hemming or is it a juggle? And same with lower tools. And lower tools we go with 3043, which is a V8. Here. And in here you can see the thickness, radius, design radius, and resulting radius. If you go with V6, you can see the resulting radius 0.8. With V8, it's 1, which is the same. Trust flat size, meaning that you always trust that the flat is correct. Depending on the designers, depending on how they design the part, is it a flat-based system or what, you can do it, but it's basically up to the person using the software. Do you want to trust it or not? Here you can see the tooling height. The only thing you are interested in is total tooling height and maximum and minimum. It always notifies you when it's not possible to use these tools in this machine. Here you can select to use these tools for all bends. You can also change them later, but usually always use the same tools in all bends if possible. And remember, as preferred tools, well, you set these current tools as preferred tools. And here, basically this is all fine, but you can also select, let's go here and select tools, and then do the same thing, but remove the use in all, and it will use different tools for this particular bend. But then we go to sequencing, which is basically managing the order of bends. At the beginning, I can see that we're going to do 2, 4, and then 1, 3. So number 2 is first, then number 4, 1, and 3. It's always a good idea to know what you're doing. It takes a little bit of time, but the longer you use the software, the longer you bend, the easier it gets. Obviously, this is a really easy part, so it's not that difficult. But on complex part, it takes a long time to know what you're doing properly. But it takes time. It takes time. Nobody is perfect at the day number 1, so there's no pressure. Then it's, do you want to see the 2D or sequence interactively? This is interactively 2D is just a 2D image. And here you can see, do you want to ignore them? Do you want to use heels, which is basically the notches here? Do you want to flip the part or rotate it, like 180 from this end here? Do you turn upper holder, upper punch, or turn die or die holder? And do you want to divide the tools so that there's like small gaps in the tools, and this is the angle. But then we go to simulation. You always have to go to simulation and simulate it, because the machine does during the simulation it checks the collision. So you can't go directly to output, you have to go through here. Hit parameters shows you the hit parameters. You can take a video, snapshots, or clear the memory. You can rotate the part. It doesn't work on simulation, so I don't know why this button exists here, but never mind. You can align the tools left, right, middle, always to the center in our machines. Reset hits, reset fingers, well, reset fingers, put it in the standard location, and you can modify or fine-tune the location of tools, fingers, and everything. If you want the fingers to be closer to the middle or somewhere in your own location, let's just say, then it works. Here you can set up management, or use the setup management, which basically means you can, if you have 3 setups here, here, and here, you can move them around as you want. Single play, it simulates 1 bend at a time, and play current hit forward, and this is the next hit, and so on. But you have to go through every single bend so that the machine knows that there's no collisions, nothing's dangerous, so you can work. You can always ignore the collisions. If it detects a collision, you can ignore it, but I suggest checking if it's actually detrimental or not. Sometimes it complains that it hits the punch, but it's supposed to hit the punch if it's a complex part or something like that. But then we go to output, which is actually, well, the output. In here, you can name and control. You can change the name of the tools if you want, or materials, which is also here, but here, advanced. But generate report, where do you want to save the report, and report multi-finger. Let's just quickly generate the report and see what happens. It takes a picture of every single bend, because it wants to show the user how the bend is actually made. And it should be now. Yeah, it's saved to here. View. It basically shows you the basic information. Quantity is always 99999, but you can change it in the controller of the machine. Approximate weight, thickness, size of the cut. The logo here, it doesn't go properly because I haven't. It's not a PNG file that I put here, it's a JPEG, so it looks like that, but on standard it's a metallics logo there. Usually it shows the 3D part here, but because this is a 2D made in the machine, it shows the 2D. Here you can see the tools. What tools do you use? Is it a heel, a left heel or right heel? What's the length, position, and what's the segment? And is it a rotated one or not? And then you can see basically the bends order. In complex parts, this is quite helpful, but in simple parts, it's not necessary to show this report to the user of the machine. But it's a good idea that it exists. Flat part takes a picture of the flat part. Pretty simple. Job time, it's a negative instead of positive, so it thinks that it takes a longer time to do something than it actually does. So it's in the proper order, let's just say, in my opinion at least. You can change the name of the NC, so what's the program name in the control, and what name does it use. These you don't have to care about, setups in single NC or setups. You can basically do separate NC files for different tool setups if you want. But we support multi-tool option up to 3 different tools, so it usually is not necessary. Generate report, or generate NC. Let's generate the NC code itself. Takes a picture, NC generated successfully, everything is fine. View, and now you can see what the NC file looks like. There's the tools, quantity, material, thickness, and so on. Doesn't have to care about this that much, but it's a good idea to know what it should look like. A lot of zeros and different numbers. And then you can open the NC folder and put it on the server or plug it to the USB stick if you want. But that's the basic idea how you use the software, so I thank you for your time, and that's it.